Okay, everyone, we're going to talk about Bohr models and valence electrons. Try to clear up anything if we have any misunderstandings, and hopefully see if we can make this out and make it easy. So we're going to look at our kind of modified periodic table again, and today we're going to make a Bohr model out of magnesium. See the 12, the Mg, the 24. We're looking at magnesium. It can also be found on the traditional or smaller periodic scale sitting right here. We're going to look, as we can see, I kind of drew it. We have 12, which is the atomic number right here. So we know the atomic number is 12. That means that using APE, that there are 12 protons and 12 electrons. So now we know the protons and electrons. We need to figure out what the neutrons would be. Looking here, 24.3, we got to find the mass, but we got to figure out if we're going to round it or not. Since 3 is 4 or less, it's going to stay the same. So we'll put 24 minus the atomic number, which was 12. We end up with 12 neutrons. And so we have 12 of each of them, 12 protons, 12 neutrons, and 12 electrons going into this. If I was to look at a normal atom, you would have 12 dots would be for like the protons, 12 dots would be for like the neutrons, and then the electrons, because they're an electron cloud, remember they're never stationary, they're always moving, you would have a level where it was just kind of shaded, which would hold two of the electrons. We have another level that would just be a shade, because again these are clouds. I mean, we can never tell. So we have 2 and we have 8, so we'd have 10, and then we'd have one more level on the outside for the last 2. Again, it would all be shaded. And all we would see are these things moving around so fast you wouldn't be able to tell what where is, and it'd be very hard to explain or draw to someone what an atom is. So what we do is we come in and we use what they call a Bohr model. So we'll be looking over here. It's spelled kind of weird, B-O-H-R. It's the last name of a guy. He created it, make things a little bit easier on us so we could actually see the pieces and the parts. So on this one, we're going to be looking at it. We're doing magnesium. Just going to put Mg just to keep it simple. Right now I know it has 12 protons. Protons and neutrons are in the nucleus. They make up the majority of the mass. So what we can do, there's 2 ways you can do this. You can put 12 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you could just write, sometimes you'll see it as protons equal 12. Either way, both of those are for magnesium. And then you'd have the neutrons, which are green. We said that there was 12 of those, so you can either put 12 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or we can put it in and put it equal to 12. The part that makes this model, the advantage or beneficial is the electrons. We have 12 of those. The first ring of the electrons can hold 2. So we have 1, 2 in the first energy level. I need 12, so the next one can hold up to 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then, so we have 2 and 8, we have 10. We still need 2 more. We'll put 1 and 2 on the outside. And so you have, this is your Bohr model. We can easily see how many protons, electrons, neutrons, everything it has. 3, 4, 5, 6, 7, 8. And then 1 and 2. So either of these, you can see them either way, but we can see the dots, but more importantly, when you compare the cloud, which is just a shading, if you're just shading a pencil, it's just a shade, here we can actually put a dot down and look at where they are and how many are in each little level going around, which is the advantage of using the Bohr model. So we use the Bohr model, really, it helps us with the electrons and moving forward with it. Now, going through to find the valence electrons, Valence electrons are the number of electrons on the outermost ring. So you find the outermost ring that has the most. So in our case, we're using 3 rings. We have 1, 2, 3. So there's 3 energy levels that are on that are containing it. The most we can put on the first level can hold 2 electrons, and then 8. And then for our purposes, we're just going to stick to anything left over will go on the third. So we're going to look at it. We'll have the dots. Your first 2, 1, 2, then 1, 2, 3, 4, 5, 6, 7, 8, and then like over here we have 2. So valence electrons are the number of electrons in the outside level. Valence electrons, they're the number of electrons on the outer level. On, it's getting harder to write. Outer level. So we're going to count it up. We have 1 here, and we have 2 here. So what we'd say, whenever we did this, is magnesium has 2 valence electrons. Magnesium would have only 2 because we have the 1 and the 2 on the very outside. We don't worry about any of the inner rings. Just focus on the outside. And so anytime we're asking for a valence electron, you can see you can find it just by counting the outside. If you don't want to draw an atom every time, there is a little bit easier way. We wrote it down this week in our notebook. We kind of looked at some of the patterns, and we're able to tell without having to look. You can use this periodic table or any other periodic table to kind of simplify it. We looked at it this week. We counted them. Everything from hydrogen going down, anything below hydrogen or within hydrogen had 1 valence electron. We looked at beryllium and magnesium. Everything in this group, it doesn't matter how far down you go, will have 2. And then you have 3, 4, 5, 6, 7. And then the outside, it shows us that all the rings are full. So you don't have to draw the atom if you don't want to. You can just come over here and then use a periodic table and just figure out where it is. Is it in 1, 2, 3, 4, 5, 6, 7, or 8? The only exception is helium. It has 2 because it only has that 1 ring and it's full. So those are valence electrons and the Bohr model, and kind of how we use the Bohr model to figure that out. Hopefully they find that helpful, and you can use it next time in class.